Hey there! In this video, we're going to go over the beginning of lesson 4.3, which is the definite integral and area. So we're going to be talking about how we can find the area between two x values, the x-axis, and a curve using basic geometry. It's very cool. So this basically says we now know that the net signed area, remember what that is, that's the area both below the x-axis as well as above added together, the negative area and the positive area, between a continuous curve f of x and the x-axis is given by that. So we've seen that. In lesson 4.2, we saw that this definite integral represents the sum of many tiny rectangles with heights of f of x, widths of dx. From a to b is what we're collecting that area. So what does that mean visually? It means that it's all of this area here from a to b, to all the way over to this area right there. All of that area under that curve is represented by that definite integral. So to be integrable over an interval, f of x must be continuous. So in order for us to be able to collect the area here, we've got to have a continuous curve, which we do there. So what does this mean visually then? What does the integral from a to b of f of x dx equal 5 mean visually? Well, as I showed you here, it means that if I take this area, which is a negative number, and I add it to this area, which is a positive number, it's above the x-axis, whereas this area is below the x-axis, the sum of that number plus this number will equal out to 5. So let's just say that, just throwing it out there, let's say that that area ends up being negative 2, and this area right here, all of that ends up being positive 7. Negative 2 plus 7 equals the net signed area of 5. That's what the definite integral tells us, the area between the curve and the x-axis. Not bad. Okay, so let's keep going with that. Now we're going to see that we can find that area when the curves are quote-unquote nice geometric curves. You'll see what I mean by that in a second, using simple geometry. So the instructions here say sketch the graph of each integrand, the integrand being the number or function or expression that is within the integral, 2, 2x, root 1 minus x squared are all the integrands. And use the graph to evaluate the definite integral. So we're going to sketch the graph of here, f of x, or y equals 2. That's what's going on there. So y equals 2, what's that going to be? Well, it's like a nice horizontal line here like this. So we draw out that sketch horizontal line just going all the way across there. And that's at the line y equals 2. And we're told we want the area from negative 2 to 6 beneath 2 but above the x-axis, or between 2 and the x-axis. So from negative 2, that would be from here to 6. 1, 2, 3, 4, 5, 6. Oh, so that's this area right in here. That's the area that we want. Well, that's a rectangle. So to find this exact definite integral, the area between that curve and the x-axis, just find the area of the rectangle. This rectangle has a width of 2 plus another 6 spots. If you count those out, it's 8 across. I'll do that in a different color there. So 8 is the width, and the height is 2. So very simply, the definite integral, or the area that we just found, is 8 times 2, and it's 16. Notice the area all takes place above the x-axis. That's why we have all positive numbers there. Okay, for this one right here, we've got the definite integral from 2 to 5 of 2x dx. So what we're going to do is we are going to graph out y equals 2x. That's our function right there. So that's got a y-intercept of 0, and then a rise and run of 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1, down 2 left 1, down 2 left 1, and so on and so forth. Now we're going to be integrating from 2 to 5. And you know what? I'm gonna throw a curveball on this one. Let's make it negative 2 just for fun. All right, let's do that. Let's see what happens there. So what I do here is I throw down that curve, just a rough sketch. Just like so. Rough sketch of the line, something like that. And now what we need to do is we got to trace out what our area is going to be. So we'll go from negative 2 to 5. So negative 2 would be over here. Ooh, that's an interesting area. All the way over to 5. So it's 1, 2, 3, 4, 5. Okay. So we got two shapes here essentially. Notice we've got a triangle here, and here we've got another triangle. But this area is below the x-axis. So let's go piece by piece and then we'll add them together. And that'll give us the definite integral. So if we look at this, this has a width of 2 and a height of 1, 2, 3, 4, negative 4. So the area of a triangle, very simply, is 1/2 the base times the height. Okay, that's not bad. So the area is going to be equal to 1/2, the base is 2, that's this. The height is negative 4. right? So when we simplify that out, the area is going to therefore be -4. That's the net signed area, that area right there. We're going to do the same thing for this triangle. It's got a base of 1, 2, 3, 4, 5, and a height of 10, if you count that up all the way up to 5. 5 times 2 is 10. There we have it. It's not a perfectly drawn triangle. It goes right up to there. So the area of that is going to be 1/2. The base is 5. The height is 10, but positive because we're above the x-axis. When we simplify that, we'll get 25. So that area is 25. So the overall definite integral from -2 to 5 is the sum of the areas, -4 plus 25, which is equal to 21. That's the net signed area. And you might be like, but area can't be negative. When it's below the x-axis, it is considered negative. I've gone over those concepts actually in earlier videos, especially when I talked about position and velocity and acceleration. For now, remember that rule. If you're below the x-axis, you have a negative height. Therefore, you get a negative signed area. Okay, last but not least, the square root of 1 minus x squared. I don't expect you to be like, well, duh, it's a semicircle, dude. We're taking the definite integral from -1 to 1, so we want the area between this curve and the x-axis. So I'm going to do this, and I'm going to go out with slightly bigger intervals. So let's say that that's 1, and then therefore this would be 2. This would therefore out be to -1, and this would be out to -2, like so. This is going to be a semicircle, and you might be like, what? It is. It's a semicircle, I promise you. And so we take this, sketch it in there, a semicircle, and it looks something like that. So how do we find the area between this curve and the x-axis? If it's a semicircle, well, the area of a semicircle is 1/2 the area of a circle, which of course is pi times the radius squared. So what we now need is the radius. Well, the radius, as we see right here, is 1, right? That's 1. And so therefore, we've got 1/2 times pi times, I don't know why I said it that way, 1 squared. When you simplify all of that, 1 squared is 1 times pi over 2. So the area is pi over 2. That's it. That'll get you the area of that semicircle, and therefore the definite integral is pi over 2. So check this video out again if you need to. All it is saying is that to find the area between a curve and an x-axis, if the curve forms a nice geometric area, rely on your geometry skills and your basic formulas to find area. It's sweet. Sweet, definitely sweet, right? Definite integral, get it? Terrible joke? Okay, see you in the next video. Peace.